Hi, in this video we will study another approach to the IP addresses problem. In the last video we understood that the direct addressing scheme sometimes requires too much memory. And why is that? Because it tries to store something for each possible IP address, while we are only interested in the active IP addresses, those from which at least some user has accessed our service during the last hour. So the first idea for improvement of the memory consumption is let's just store the active IPs and nothing else. Another idea is that if our array-based approach from the last video has failed, then let's try to use list instead of an array. So let's store all the IP addresses which are active in a list, sorted by the time of access, so that the first element in the list corresponds to the oldest access time during the last hour, and the last element in the list corresponds to the latest, newest access from some IP address to our service. Let's jump from here right into the pseudocode because it's pretty simple. We again have our procedure update access list, which takes in the log file log. It also takes in I, which is the index of the first log line which hasn't been processed yet. And also it has input L, which is the list. And instead of some abstract data structure C from the few first videos, and instead of the array A from the direct addressing scheme, we put parameter L, which is a list, into this procedure. And this is the list with the active IP addresses. So our code has two parts. First deals with new lines and second deals with the old lines. We just go starting from the first unprocessed line, and if we need to add it to our list because it was processed during the last hour, we just append it to the end of the list. And now again, the last element of the list corresponds to the latest, newest access from some IP address. And note that in our list, we will store not just the IP address, but both IP address and the time of the access. And then we will go to the next element in the log file and go while we still have some log lines which we need to add to the end of our list. And in the second part, we just look at the oldest event during the last hour, which is corresponding to the first element of the list. And if that is actually before the start of the last hour, then we need to remove it from the list. And so we just do lpop. And we do that while the head of the list is still too old. And when we stop, it means that all the elements in the list are actually with time during the last hour. Why is that? Because the list is always kept in the order by increasing time of access. When we add new log lines to the list, we add only those which have time even more than the last element of the list currently. And when we remove something from the list, we remove the oldest entries. So all the entries are always sorted, and as soon as we removed everything from the start which is too old, all the entries in the list are not too old. They are made during the last hour. So this is pretty simple, and now we need to answer questions like whether my IP address was used during the last hour to access the service and how many times. To answer the first one, we just need to find out whether there is an element in our list with the given IP address. And that is done by procedure find by IP, which is different from the standard find procedure of the list by the fact that we search not by the whole object, which is a log line which contains both IP address and time, but we search just by the first field, by the IP address. So our list contains tuples of IP addresses and times of access, and we only look by IP address. But the implementation will be the same. We'll just go from the head of the list to the end of the list and compare the IP field of the log lines with the IP address given as the input. And if it coincides, we return this element. Otherwise, we return that there is nothing with this IP address in the list, and we return some special null value. So then in the access last hour, just compare the result with null. If it's not null, then this IP address is in the list, otherwise it's not. And to count the number of times our service was accessed from a particular IP address, just need to count the number of log lines in the list which have the same IP address. And that can be done by procedure count IP of the list, which again differs from the standard count procedure in the list by the fact that it counts by the first field, not by the whole object, which is a log line, but it just goes from head to the end of the list, compares the IP field with the given IP, and if they coincide, it increases the counter by 1 and returns the counter in the end. So this is all the implementation. Now let's analyze it. Let n be the number of currently active IPs. Then the memory consumption is big O of n, because we only store the active IP addresses and the corresponding times of access, but the times of access only add constant memory per active IP, so it's all in all linear in the number of active IPs, which is much better than the direct addressing scheme, because it required amount of memory proportional to the number of all possible IP addresses. And here we only require amount of memory proportional to the number of currently active IP addresses. What about running time? We know that the standard lists procedures such as append, top, and pop all work in constant time, and that's why the update access list works in constant time per log line. Of course, any particular call to update access list could take more than a constant number of operations if we need to add more new lines to the end of the list or remove many old lines from the start of the list. But for each log line, we will only append it at most once, and we will only remove it from the beginning at most once. So it's constant time per log line plus constant time per each call of update access list, just to check whether we need to append something and whether we need to remove something from the beginning. But this amount of operations can be controlled by how often do we actually call update access list. What about answering the questions? We know that find by IP and count IP have to go through the whole list in the worst case, and actually count IP has to go through the whole list all the time to find out how many log lines have the same IP as the given one. And so access last hour and access count last hour are both linear in the number of active IPs. And that is actually no good, because even without introducing any additional data structures, we could just take the log file, take the last line in it before the current time, and go back from it and just look through each log line and compare its IP address with the IP address in the question and count how many times it occurs during the last hour, and just stop as soon as we go through the border of the last hour. And that will take the same time without any additional data structures. So this solution is not more clever than the trivial approach. So we failed somewhat with direct addressing scheme, and we failed with this list-based approach. Is it overall a failure? Well, no. In the next videos we'll combine the ideas from direct addressing scheme with the list-based approach, and we'll come up with a solution which is both good in terms of memory consumption and is much faster than the trivial approach in terms of the running time.